And the last example I'll give for a POSIX compliant distributed file system is a commercial file system. There are numerous commercial file systems out there. This is not an endorsement one way or the other. It happens to be a file system that my team has experience with and that we've used successfully at the University of Notre Dame, and that's the Panasys file system. The software and in this case the hardware is proprietary. Their current version in terms of a file storage system is the ActiveStore 20. Implementation, they have storage and metadata servers and clients similar in terms of, you can conceptually think of this as Lustre in terms of building out servers that for metadata, servers that are for storage, and clients. It actually handles block allocation differently than a Lustre file system. That's probably too low level in the details for this course, but there are some differences in terms of how the files are broken apart into block storage and how those blocks are distributed across the Panasys system. So significant differences from Lustre, but from the high level similarities in terms of there's metadata servers, there's storage servers, and then all of the compute nodes run clients. In this particular configuration, and kind of a hallmark of this particular appliance, is a high CPU and network to disk ratio. You can see in the images here, each one of those blades has a couple of disks, but then also has processing power associated with that, which allows a significant offload of the metadata or the storage servers in terms of the compute requirements. So you can move a lot of data in terms of pushing it through the CPU requirement and the network requirements when we're doing data access. And also, they have significant flash acceleration. You'll see this in a lot of distributed file systems now. So that just adds an additional tier of file storage. When I say flash, you can think of like SSDs. And there's additional technology coming out that allow another level that's significantly faster than disk, typically less capacity than the disk, but now the file systems are smart enough to put the most utilized files within the flash. The lesser utilized files or the cold files can stay on the slower disk. But you can imagine within one of these blades a couple of disks and some SSD storage, potentially even RAM. So you've got multiple tiers of storage at various speeds and capacity, such that you can try, if you have a data set that requires heavy processing, a small number for a significant amount of time, that flash acceleration can help quite a bit. And because it's a commercial product, most of them pride themselves, Panasys included in that group, on modest tuning and admin, such that you can get the appliance, you can plug it in and start computing in terms of having access to that powerful distributed file system that can support many concurrent clients. Also fault tolerant. You can lose multiple disks, you can even lose entire storage nodes, and the system has self-healing capabilities to handle that. Near linear scalability, similar to Lustre, with additional hardware you can add to that excellent aggregate I/O performance and continue to add the number of concurrent clients that you can handle. We've in the current versions, good to really good small file performance. Like Lustre, some of the early versions had trouble handling the metadata for large numbers of small files, but with caching, additional CPU, that sort of thing, especially because of the high CPU to disk ratio, they've done a nice job of improving their small file performance over the years.